Let us look at some mathematical operations on rational numbers. We can ask some of the questions. Is 7 root 5 irrational? Right, root 5 itself is irrational, 2.236, and it keeps on going. Okay, if you take a calculator and multiply 7 by root 5, you will get 15.62, and the decimal digits keep continuing. That means 7 multiplied by root 5 is also irrational. So whenever you have an integer and you multiply it by an irrational number, you get the answer also as irrational. Okay. Now, if you want to add two sets of irrational numbers, say 2 root 2 plus 5 root 3 and root 2 minus 3 root 3, you can assimilate the similar irrational numbers together. So you have 2 root 2 and a root 2, that becomes 2 plus 1 root 2, and root 3, when you assimilate it together, it will become 5 minus 3 root 3, so which will give you 3 root 2 and 2 root 3. Okay. So here you have accumulated similar irrational numbers, and you have manipulated and simplified them. Okay. So if I multiply 6 root 5 with 2 root 5, what will I get? So that is nothing but 6 into 2, right, multiplied by root of 5 whole squared, because there are 2 root 5s. Okay. So a into a is a squared. So root 5 whole squared, that is root 5 whole squared is nothing but 5. 6 into 2 is 12. So 12 5s are 60, which is a rational number. So here you can see, when you multiply two irrationals, there might be a chance that you get a rational number also. Then we have 8 root 15 divided by 2 root 3. Okay. But remember, 15 is 3 into 5. So root of 15 can be put as root of 3 into 5, which is root 3 into root 5, 8 root 3 into root 5 divided by 2 root 3, and root 3 and root 3 will get cancelled, and 2 will cancel 8 4 times, so you get 4 root 5. So which is also irrational. Hi friends, let's look at how to represent square root of any number x on the number line. To find square root of x on the number line for any number x. X can be 9.6, 10.3, 5, 2, anything. Okay. So the first step you have to do is draw a segment AB whose length is x. Okay. And then the second step is you have to extend that line segment to BC, which is 1 unit in length. Okay, so AB is x, BC extended is by 1 unit, and the third step is you have to bisect this AC into 2 equal halves, and the bisection point has to be named O. Okay, and we can draw a semicircle with O as the center and radius is equal to OC. Okay. So OC is nothing but x plus 1 by 2, because you have bisected it. Remember that. And once you do that, draw a perpendicular line BD to AB, and that will intersect with the semicircle, giving you the length of root x. So BD will be your root x. Okay. So this is the procedure. So let's do it. So I want to find root of 5, let us say, on the number line. So first I draw a sort of line whose length, let's say I want to find root of 4, right? So we know it's 2, but just for the sake of doing the exercise, extend it by 1 more unit. Okay. So AB, right? That should be a 4 actually. It's not 5 units. It should be 4. And then we bisect the segment AC. Okay, that 5 should be anywhere you see the 5 in this example, it should be a 4 actually, because we drew a segment whose length is 4. There is a mistake in this video, please correct it. It's not 5, it's always 4. Okay. So we bisected the segment, okay, and that segment is at O, okay, that bisection is at O, Then what we did is we drew a semicircle of OC, okay, radius OC. So that gave us that semicircle, okay. Then when you draw a line perpendicular to the segment AB at B, okay, that's what we are doing using the protractor. We are constructing a -90-degree line there, okay. So, and when the line intersects with the semicircle, that's where you get square root of AB, okay. So that is should be root 4, okay, not root 5. So there's a mistake in this video. Wherever you see 5 or root 5, it should be 4 actually, okay. So once we get this BD, which is the needed square root, we can transfer it to the number line by drawing an arc from B to D to the number line with B as the center, okay. So that will give us basically the square root of the number. So you can see that that should again be root 4, okay, not root 5, okay, because initially we constructed a line of length 4, okay, and we can just connect OD, and we can see that it is equal to OC, just for the observation sake. And to prove that BD is actually square root of x, we know that OD and OC is equal to x plus 1 by 2, because that's how we constructed it by bisecting AC, and OB is nothing but the OD or OC minus 1, that is x minus 1 by 2, okay. And if you apply the Pythagorean theorem to the triangle OBD, so you'll get OD square is equal to OB square plus DB squared, okay. So hypotenuse square is equal to adjacent side square plus opposite side square. So OD is, we know, is x plus 1 squared by 2 squared, because it's x plus 1 by 2. That whole squared will give you 2 squared in the denominator also. And OB squared is x minus 1 whole squared by 2 squared. And BD squared is what we are interested in finding out basically, okay. And by sending x minus 1 to the other side of the equation, the denominator, common denominator is 2 squared, which is 4. You get x plus 1 squared minus x minus 1 squared, okay. This is in the form of a squared minus b squared, okay. So we know that from our previous classes that a minus squared minus b squared is equal to a plus b into a minus b, okay. So here what we can say is that is x plus 1 plus x minus 1 will give you 2x, and x plus 1 minus x minus 1 will give you 2, giving you x. So BD is equal to square root of x, okay. So this proves that, you know, when you construct like this, actually what you're getting is right. Hi friends, let's look at exponents of real numbers. So there are some more exponential facts that we need to discuss about rational numbers. Whenever there is a square root and two numbers are multiplied, you can split the square root between the two numbers. So root AB is equal to root A into root B. Similarly for division, root of A by B is equal to root A divided by root B, okay. So that is one thing. And similarly there are other mathematical formulas, root A plus root B into root A minus root B, okay. This looks like A plus B into A minus B, okay. What is A plus B into A minus B? That is A squared minus B squared, okay. So in A's place we have root A, so root A whole squared minus root B whole squared, okay. So that will give us A minus B, okay. So even the rational numbers, you can apply formulas such as A plus B into A minus B is equal to A squared minus B squared, and so on and so forth, okay. Similarly, if you have a plus root b into a minus root b, again applying the formula, you'll get a squared minus root b whole squared, right, which is nothing but a squared minus b. Okay, so other exponential sort of identities are, if you have a m by n, that is actually nth root of a whole to the power of n. Okay, let's give you an example. Suppose I have 9 the power of 3 by 2. Okay, what this means is square root of 9, because 1 by 2 of 9 is nothing but square root, whole power 3. Square root of 9 is 3, whole power 3 means 3 into 3 into 3 3 times, that is 3 3s are 9, 9 3s are 27. Okay, so these are the way in which we denote the exponents of rational numbers. And if you have a power p into a power q, that is equal to a power p plus q. Okay, so if there are exponents getting multiplied, their exponents get added up. For example, if you have 2 plus 3, 2 to the power of 3 into 2 to the power of 2, 2 to the power of 3 is 2 into 2 into 2. Okay, 2 power 2 is another 2 2's. So now there are 5 2's. So that is 2 power 5. So what has happened? The exponents have got added up. The 3 and 2 are exponents, they got added up and they have given you 2 power 5. So remember this, a power p into a power q is a power p plus q. Similarly, a power p divided by a power q is equal to a power p minus q. For example, if you have 3 cube divided by 3 squared, that is equal to 3 into 3 into 3 for the numerator, 3 into 3 for the denominator, and after the cancellation you will get 3, which is nothing but 3 power 1, okay, which is same as 3 power 3 minus 2. So the division case, the exponents have sort of subtracted from numerator's exponent and denominator's exponent. Okay, so a power p whole power q is equal to a power p into q. Okay, this is whole power, it's not multiplication, it's a power p whole power q. So 2 power 2 whole power 3. Okay, 2 power 2 is 4. If you raise it to the power of 3, you get 3 fours, that is 4 fours are 60, 64 are 64. Okay, but what is 4? It is 2 into 2. Again, for the next 4 you can write 2 into 2. Again, for the next 4 you can write 2 into 2. So you have 6 2's, that is 2 power 6. So what has happened is 2 power 2 into 3 has happened and it has given you the answer. So a power p whole power q is nothing but a power p into q. Okay, and similarly a power p into b power p is equal to ab times power p. Okay, so if you have two rational numbers raised to the same power, they can be multiplied and raised to the power simultaneously. So if you have 2 power 3 into 3 power 3, for 2 power 3 there are 3 2's, 2 into 2 into 2. Similarly, for 3 power 3 you have 3 3's, 3 into 3 into 3. You can take 1 2 and 1 3 and get a 6, another 2 and another 3 and get a 6, and another 3 and another 2 and get a 6. So that will give you 2 into 3 cube. Okay, because 6 is 2 into 3, so there are 3 6's.